Hello and welcome back. Today in module number 11, we are going to talk about chi-square test. And this is a real test and with a lot of implementation and a lot of things that I will cover throughout my presentation. But in Canvas, I will provide you with three different pages. The first page, which you see right now, is about what is chi-square test means. What does it consist? For example, it is designed for categorical data and not regular data, which means that the data has to be sorted based on categories. And it also, the chi-square test also discuss the issue of null hypothesis. So in my Canvas outline for this module, you will see, first of all, the chi-square test. You will have my notes that I will use in my presentation, but you will also see how to conduct the chi-square test in R and what is the application on it. In this case, we are going to talk about data frame in R. Data frame is the ability to store one more container of data, and it is really easy when we are using a chi-square test to use the data frame. And the last issue that you're going to see is whereas my passion is basically the idea of visualization in R. And I gave you all the information about the creator of the package, Wickham, the ggplot2, his work in RStudio, his a book about his packages, and his GitHub account where he published most of his work. So let's start. So chi-square, and this is probably what we will learn, and based on what I got from some of you who ask for more example or more directions how to conduct things, I think this lecture will be much more focused with regard to problem solution instead of me talking about some the implementation itself. So let me try to be more pragmatic. So the idea of chi-square usually entails the idea of tables, contingency tables. And why is it they are so useful? They are useful because they allowed us to do comparison and ability to observe with two or more characteristics out of that, which means that in a sense, if we will take example left-handed versus gender, and what is the idea of it? We have two categories. Left or right hand is one category. The second category is gender. And the idea that if we'll take an example of 300 children, this is what will come up. So the idea of a table is that we're able to provide more information about those tables and about what they consist of. Example, female, it consists of 120 people out of 300. Male consists of 180 children out of 300. Left hands usually are in minority and consist in this sample of 36, compared to the right hand is 264. So again, the idea of this type of table is to provide summary in order for people to understand. In this proportion or this idea, we talked about in the past, we talked about x squared test for difference between two proportions. And we talked about that in the context of hypothesis. So if hypothesis is true, the proportion of left-hand females should be the same as the proportion of left-hand males. And the two proportions should be the same as the proportion of left-hand people overall. This is with regard to the x squared test. Now, let's talk about what is the chi-square test means. In this framework, we have the idea of the x square. And in this case, we are calling out all the cells. We are talking about the F F0 minus Fe squared divided by Fe. The F0 is the observed frequency in a particular cell. The Fe is the expected frequency in a particular cell if the H0, the null hypothesis, is true. So basically, the chi-square is built in for your hypothesis statement in order for you to create or test if your hypothesis is correct or not. So again, the idea here is that x squared for the 2 by 2 case has 1 degree of freedom, and we talk about the degree of freedom in the previous modules, and in this case we are able to see where we accept or reject the null hypothesis, and how do we do that with regard to the rule that says that bigger or smaller than x squared. So this is where we are at with regard to the decision issue. How do we compute the average proportion? The average proportion is usually the x1 plus x2 divided by n1 plus n2, which basically is equal to x divided by n. In this case, if there are 12 females and 24 left hand, we add them up together and divided them to 300, which is the overall proportion, which is equal to 0.112. And based on all 180 children, proportion left hand is 0.2. Okay, so finding the expected frequency. And again, this is something that we talked about it in the previous module, and that's why it's important for us to explore all the possibility that the p-hat has allowed us to do. So to obtain the expected frequency for left-handed females, multiply the average proportion of left-handed by the total number of females. So to obtain the expected frequency for left-handed males, multiply the average again by left-handed by the total number of female. And again, it will be, in this case, what we expected to have in the female is 14.4, in the male is 21.6 with regard to left hands. So again, observed versus expected frequency, and something that you will need to know with regard to chi-square and what is it really means. But again, the table allowed us to do that in that sense with that regard. Okay, so now let's go back to the chi-square and let's see what it will allow us to bring in that question. And in this case, if we will calculate the chi-square test in this numbers, we will come up with 0.7576, which means this is what we will need to do. 12 minus 14.4 square root divided by 14.4, and we will come up with that result. In this case, it will allow us to come up with a point where we can say that with 1, the degree of freedom is equal to 3.841, which means that we reject the null hypothesis. Otherwise, we do not reject the null hypothesis. And again, I want you to think about the big picture here, because this is what we are trying to achieve. The big picture with regard to chi-square and what does he provide us in this case. And to conclude, there is no significant evidence that two proportions are different at alpha is equal to 0.05. And so this is where we need to approach and how to apply that. So the x square test for the difference among then the two proportion, in this case, we expand the square to x square test, the case of more than 2 independent population. And in the case, we will expect again, C minus 1 is the degree of freedom, assuming the cell of the table expected to frequency of at least 1. So overall, what we are doing here is the idea of we are trying to calculate the proportion. We are calculating the expected frequency for the C category, in this case 2 by 2, and we are doing the same rule with regard to accept or reject the null hypothesis if those C minus 1 is a proportion for that. Okay, so this is, if we will use it manually, this is what you will do. Now to the open source R. So the idea in the R that we have a lot of options with regard to chi-square test. In case of distribution, we can use normal distribution, D normal distribution, and B, and all of that are fine. And we will allow us to find the function of at a specific point, produce critical value, and calculate the p-value. But in this case, most distribution require more than one definition to the shape of distribution. The F distribution, as we talked about it throughout the semester, is a right shape distribution, and when we have referred to F distribution, the number degree of freedom are always giving first and switching the order of the degree, which means that the F is always bigger or smaller in that case. So for the F distribution, you need to degree of freedom, the df1, and the denominator, the df2, to generate an example 50 random numbers in order for us to do that. So the study of following information, age distribution of library online user, report that 35% between the age of 18 to 35 old, and 51 are between the age of 35 and 64 years old, and only 14% are 64 years old and older. So this is the proportion of online library data that we have, and I took it from my book. Our revise will give us the following information. But suppose that the data result in a random sample of 200, and this is based on Canadian library users. Based on those data, sample data, we can conclude that one or more of those age groups. So in this case, we need to do the expected values of it. So what can we do? How can R can help us to resolve that? We can create two variables, age and frequency. So under the age group, we can count, or we can create a container that will hold the numbers. The frequency, we will call it a frequency container, and the table will present us the age and the frequency. Then, after we create this table, we are going to use the command of chi-square test in order for us to do that. So the chi-square test is called chris.k.test, and in the container it will contain the table, the age, and the frequency, and it will give us the result. In this case, s square is equal 6, the df is equal 4, the ps value is 0.1991, but it will receive a warning that the R will give us, which means that in this case, the frequency square appreciation might be incorrect. So this is how we do things with regard to the R, and I want you to be fully aware of it. And again, in the assignment, you will get the example. I posted the example in that test with regard to children and how to do that, and how to observe and how to apply that. But again, this is where we come up and can fill the gaps in that with regard to visualization. So some of you already took my visualization course, and if you're not, I will offer it next semester, but I highly recommend that you will do that, because in a class I'm talking about basic graphics. We are going to look at two specific packages. One is Lattice and one is ggplot2, and we will learn in this example how to do that. So the idea here is the basic graphics is what Excel can do, and it can be fun and it can be exciting, but again, this is not the point that I'm trying to achieve in this case. So there are 9 basic ways to plot a set of points. We use those to define the type of arguments. One of those ways, P is the point, I is the line, B is both points connected by the line, C is just the connection segment of the B, O is the over plot, points and line over plot each other, H is the histogram, S the stir, S is the alternative stir, and N is the none. So in this case, this is what we are getting out of our example. So points types. There are 25 different points that can use by defining the argument. And point 21 through point 35 are multiple color points, which defines the fill color of those background. So we have some settings that we need to encounter, 1 to 25, and those are the issue that we need. We also have the line types, and it goes to 1 to 6, and again, depending what your objective. The weight and the size is also part of your definition of how do you want to display your graph, and in this case, it will display the character X times in this case, and the colors, again, it's 1 to 8, but R has 659 colors, and you can choose the type of colors you want to display, and you also can use patterns in this color pen, example rainbow, heat, or any other type if you like to. Excel often use that, but I prefer the R visualization. In that case, the colors seems to be more natural than in Excel. We also look at any of those function and a number of n, which will return the number of colors from a palette as a vector. So in this case, we're going to pass them as well, such as alpha, which is controlled transparency. And the idea here is if we will use, for example, the gray palette is different when the palette has to take the vector value of 0 or 1 in order for you to apply that. So this is the scale of the palette with that regard. Building up the plots, and again, this is a simple example, but we can actually add some color to it and some title in order for us to make it a little bit interesting or a little more attractive or communicated. Is this good enough? The answer is no, of course not, because your professor is mad about visualization. So I always expect that you will build more and experiment more. Open your eyes. This is something that I cannot force you to do. You have to expose yourself to it and learn it by yourself. There's packages that generate visualization. One of the first visualization packages in R was the Lattice. And the idea was that it will be able to provide some multi or 3D visualization and ability to add to it in order for you to do that. This is the end result of the Lattice package when you run it. So in this case, it calls, you have to install it the first line, the installment, and then the library, and then you're going to say, okay, what you want the R to do is, in this case, XP plot the data set and the lot and the data, and how to display it in order for it to display something like that. Note the following commands do the same thing. So again, I can play with it, I can apply that. Why do the people use this type of package? Usually it has more powerful. It's also used as animated and ability to edit and save. So the formula in this case is that let and long is the way for us to formulate the working formula for this plot in order for us to do that. And in this case, x and y multiplied by y is way for to us to communicate with the package or apply to the idea of it. In histogram, in this case, this is the outline. We are calling for histogram. We are saying that we want it with the height, and we provide some description to it and how to apply to it. And in this case, it will give us the result. However, it also have a wireframe, which is a three-dimensional platform if we want to do that. In order for us to apply the wireframe, we need to declare it, and then in the end, to display it as it is. So you have the attributes, is it true or false, the aspect, and how to apply that. This is the result of this package. The last package, and this is my favorite package, is the ggplot2. I am giving you here the reference to Handley Wickham. I hope one day I will be able to bring him to the campus. I hope one day the university will be able to pay for his presentation, but he is a I don't know about your knowledge in rock, but he is the superstar of the R community. He's well respected and well known. He has also has a GitHub link that you are able to see. So his structure of the ggplot3 composed of 5 elements: the aesthetics, the geometrics, the statistic, the scale, and other elements that the package provide. The coordinate system, the facing, the position, the data, the annotation for the data, and other things. So the idea of the aesthetic is to convey information with the aspect of the X position and the Y position, the size of the element, the shape of the element, and the color of the elements. The geometrics is the idea of the plot and the shape of the points, the line segments, the bar, and the text. The third aspect is the scale. And in grammar of the graphic, the scale controls the mapping from the variable in the data static. So how do we do a scale in ggplot2? We are using the ggplot2 to scale to be determined automatically. So we can do that by filling out colors in the geo underscore points in order for us to do that. So the points, we have ability to scale the shape, we have the ability to scale the size, the lines, the same thing with a line type, with a weight, or the bar, what is the X, what is the Y. We can scale the colors or outline the colors, and the text label that allows us to do that. And as a result, we are getting something like that. I'm using a data set that calls empty cars, which is 25 or 26 lines of cars, and the attributes with regard to the engine, the other components of the car. I don't remember right now on top of my head, but it will give you the MT versus the the attributes, and in this case, the speed that the car can ride, and in this case, it will give you the x interpretant. In this case, will be equal 5. So again, the code behind it is the set of the aesthetics, the data, and the other arguments passing over the other layers. The show legend, or the show dot legend, show this layer that include the legends. That is, default include any aesthetic that are mapping. False never includes, and true always includes the x interpret, the y, the slope, and other controls of the position. So it's up to you to decide how do you want to show the shape or the legend. Next example, again, I'm using another key component that in open source R we learn quite a lot, which is the data frame. What is a data frame? It holds the variables in one container, one large container that has the value of x, y, or z, or in any other container. And by doing that, we are able to apply more than one set of data set, and by doing that we're able to compare. In this case, I'm using 1 to 10 in x and 1 to 10 to y, and I'm combining that. I will call it df, which is the standard definition of data frame, and by doing that I will be able to go beyond the set, not only comparison, but treat them as what they are standing by. So in this case, this is the result. So what makes the ggplot2 so unique? We are talking about layer by layer. All ggplot plots begin with the function ggplot2. So, and it takes two arguments, the data, which is really important, and the aesthetic of the data, so you can map the plot elements. As you can see, the second argument, the aesthetic, is not normal arguments, but more a functional argument. Since we will never use the aesthetic as separate function, it might be best to think it is as a special way to pass a list of arguments into it. I highly recommend that you will visit ggplot2.org, which now moved to another location, another website, but this is the foundation of the shape. I want to end up positive notes about maps, and some of you talked to me about that and want to display it in the final project. So again, based on your request, based on your communication, the better you communicate with me, the better I'll be able to present to you other options that are provided. Three of the students in the class asked me how to apply a map into the final project. So in this case, I will use a package called reshapes2, and which will create a map. So ggplot and maps, in this case I'm calling for the ggplot2. I'm going to create crimes as a data set, and it will present it by state, and in this case it will present the crimes based on all the type of crime: murder, assault, rape, and urban pop. And so again, this is the power of R. So overall, we talked about the K-square, and I hope it will make more sense. I also gave you some reading material on the subject, but I want to, again, because we are ending very closely to ending of the semester, one of the things that I always keep myself, or keep my students in visual introduction to visual analytics, is the idea that visualization help us to keep track of what we are doing. And in this case, using the R and using the ability of R to visualize help us to sort things out, to help us to visualize, that will have a platform that we'll be able to do. So this is all I have for this class, for this module. I hope you enjoy it. I hope you do not forget that In this module, we talked about the chi-square plot and how to do that. I show you an example of how to apply that directly with the R, with that regard. And in this case, the idea is that we are using the table and we are using a squeeze test in order for you to do that, and we provide the two attributes that attach to it, and by doing that we are able to do the chi-square test. That's it for now. I hope you enjoy it. I hope you have more questions. Please do not hesitate to ask. Until next time, have fun.